All right, well, welcome everyone. It's a few minutes past 10 a.m. on the East Coast of the United States, and looks like we're approaching 90 participants. Welcome to the seminar series on conservation impact evaluation and implementation science. First, I want to introduce myself. I'm Sheila Reddy. I'm the Senior Director for Conservation Impact at the Nature Conservancy, and I'm taking over hosting from Paul Ferraro. So my co-hosts are Rachel Martin from the Conservation X Labs. She's a research manager, and also Seb Costado from Conservation International, who's a senior manager focused on social sciences and impact evaluation. So as you know, we've had an all-star lineup of speakers, and this is our 11th seminar series, and it's only going to continue. So we host these seminars on the first Tuesday of every month. So welcome after a short break. Hopefully many of you got to see the great presentation by Luke Sanford on during May. And now we're pleased to have Robert Heilmayr from UC Santa Barbara, who will be talking about conservation impact evaluation using remotely sensed data. And this is continuing a theme that we've been covering this year, integrating the latest science and technology. And then upcoming in October, we're pleased to have Michael Masha, who is now at Duke University, and he'll be talking about solving the mystery of marine protected areas performance, long-term monitoring systems, and impact evaluation for evidence-based policymaking. But before we get into it, I want to do a little bit of housekeeping. So of course, we'll start with our speaker, Robert Heilmayr. We'll have a moderated question and answer session moderated by Seb. And for the moderated Q&A session, we ask you to start posting your questions in the chat. You can do this as you have them. However, we'll handle questions at the end. Also, I want to note that we do have the functionality to have a live transcript. So please check that out under the button More, and you'll find live transcript. We'll also be recording this seminar, so you can follow up on it on our website. And please, let's keep this as a lively discussion, and let's bring it online so you can share things via social media, and you can use our hashtag Tuesdays with Team Counterfactual and tag us at IDoImpact. So before we go into the seminar, I do want to remind you of the purpose of the Impact Evaluation Working Group. We're currently a provisional working group, and we do need your support to become a full working group. So check out the bottom link, and please sign up and vote to support us becoming an Impact Evaluation full working group. I think we're only short about 5 signatures, so please do that today. You can also find out more and get involved via the Society for Conservation Biology website. You can follow us on Twitter, and you can sign up for our email list. So with that, let me turn it over to Robert, who will be talking about conservation impact evaluation using remotely sensed data. Over to you, Robert. Let me end my slideshow and hand it over to you.
Great, thanks so much, Sheila. Hopefully you can see my slides now. So it's an honor to get to present here. I've really enjoyed the last 10 of these seminars. It's been just such a fantastic community to really dive into the breadth of work being done on improving the impact evaluation of conservation interventions. Today, I'll be presenting some joint work with a former PhD student of mine, Alberto Garcia, on kind of the combination of impact evaluation with remotely sensed data, some opportunities and challenges that we've kind of identified in trying to bring together these two disciplines. But I know we have a pretty interdisciplinary audience here. So before I dive into the econometrics and the remote sensing technical details, I kind of wanted to provide a quick motivational background. So, a lot of my work is trying to understand the impact of various private interventions seeking to slow deforestation. So one study that I led a few years ago was digging into whether the Amazon soy moratorium actually slowed deforestation in the Brazilian Amazon. And this was work with Holly Gibbs and her lab at the University of Wisconsin. But the Amazon soy moratorium was really this kind of interesting effort by the major soy traders, Cargill, ADM, Bunge, to come to the table with Greenpeace and other activist organizations to try and find a way to end soy-driven deforestation in the Amazon. And the solution they came up with was to basically commit the companies to not buying any soy from farmers that were engaged in active deforestation in the Brazilian Amazon. So really interesting, kind of innovative policy design. But the question was, did this actually have an impact? So it was adopted in 2006. We started looking at this around 2016. We had a decade of data post the soy moratorium's adoption, and we really wanted to know what was the avoided deforestation that that policy helped create. And so what we did is we turned to kind of the remote sensing archive. We looked at satellite imagery, or actually here it was kind of derived satellite products, to understand the timing and the location of deforestation across the Amazon biome, which you see in this little inset in green, the part of the legal Amazon in Brazil that's in the Cerrado biome, which is this kind of pink highlighted area in the inset, and then outside of both, so in the Cerrado biome outside of the legal Amazon in yellow. And we were able to track those deforestation patterns using remote sensing to kind of come up with a sense of, okay, what was the deforestation rate here in the Amazon biome in green before and after the ASM was adopted. And what we really were after, the goal of this whole project, was to create some counterfactual deforestation rate. What would have happened in the Amazon biome if the ASM had never been adopted, right? We want to know what this dotted green line is. We can't actually observe that. That is a state of the world that never existed, but we need to know that in order to be able to calculate that avoided deforestation. How much did the soy moratorium reduce deforestation? So how do we go about that? Well, theoretically, what we really want is we want to know for every pixel across this, band of the Amazon biome, what happened with the policy, which we can actually observe with the satellite imagery. But we want to also know what might have happened without that policy. And here I'm going to use a potential outcomes framework notation. So it's basically just saying for every pixel I, some outcome Y, which is our deforestation here. And then with the policy is denoted in parentheses with 1, and without the policy is in parentheses with 0, right? So we're comparing these two states of the world. And here, this kind of fake data I've created, you see that there's just more deforestation without the policy. So what we want to know is this pixel level treatment effect. How would each pixel have differed in these two different states of the world? And using that, we can actually calculate what's called the average treatment effect on the treated. This is our estimand. What we're trying to calculate, the whole goal of the paper, is to get at this ATT, which is just the average of each of these individual pixel level treatment effects. So, what is the average reduction in deforestation across the entire Amazon biome where this policy was adopted? How do we actually get that counterfactual? So I've kind of hinted that, the big challenge is we never can observe this counterfactual dotted line. We can't observe that yi0. So we have to come up with creative ways to calculate what that counterfactual might have been. And we could use experiments for this. There's been really amazing work using experiments within the conservation science literature, but there's also a variety of quasi-experimental methods that we could turn to. So Paul has done a ton of work in this space. One recent paper that I really like looking at cash transfers is listed. You could do propensity score matching, which I've used in the past to look at things like FSC certification, instrumental variables, synthetic control, regression discontinuity design, double machine learning, as Luke showed us, a couple of months ago before we broke for the summer. I know there's people in the audience that might not be super familiar with all these different methods. There's some nice reviews specific to conservation and deforestation that are really great resources to kind of introduce the key ideas of these different quasi-experimental methods. But the point here is that all of these different methods, their primary goal is really just to calculate what this counterfactual might be. There are different ways to get at that. and so that we can actually measure the impact of a conservation intervention. So there's all these resources, and they're increasingly being applied to remotely sensed data. So doing kind of a quick scrape of Google Scholar about a year and a half ago, kind of found that we're now over 1,000 papers that cite the Hansen et al. Data set. So this is a single remotely sensed data set of deforestation around the world. Some people know it as Global Forest Watch or the Global Forest Change data set. This one data set has now been cited over 1,000 times by papers that are using some combination of keywords of econometric, causal inference, impact evaluation, regression discontinuity, right? And it's growing year on year. So there's a huge interest in using remotely sensed data coupled with these econometric methods to try and understand the impact of different conservation interventions. These papers ask, a wide variety of formulations of this question. How does something affect deforestation? Conflict, or maybe protected areas, payments for ecosystem services, indigenous tenure reform, zero deforestation commitments, wide variety of different kind of fundamental research questions, but they're all kind of turning to this methodological combination of remote sensing and econometrics. So in this paper, we're going to try and understand whether that actually works. So our big question here is going to be whether applying standard econometric methods to remotely sensed data generate accurate estimates of the impacts of conservation policies. We're a little bit worried about this because remotely sensed data are just slightly different than a lot of the traditional outcome data that are used in these econometric models. And I'll dig into those differences in a moment. But the key at this point is just to know that the answer is frequently not. Many previous estimates may be biased, but we also propose some pretty simple solutions that allow you to sidestep those pitfalls. So here I'm excited to present to this community because it's a lot of people that I know that are doing really great work here. Before I had really dug into this, was structuring my models in slightly imprecise ways that might have introduced bias. And so for me, it's been really helpful to sit down and spend 3 years thinking through all the math behind these problems. And hopefully the paper can serve as a useful roadmap for people to both interpret the existing literature, but also to structure their studies to give more reliable answers in terms of the impact that different conservation policies have had. So I know we're coming from a variety of different backgrounds, so I'm going to quickly spend a bit of time kind of touching on the foundation. So introduce what I'm talking about when I'm talking about remotely sensed data on deforestation, what that data actually look like. I'm going to touch on the specific quasi-experimental methods that our paper looks at, which are kind of panel econometric methods of impact evaluation. Then I'm going to quickly cover our simulation model, which we use to test alternate models. And then spend the last part of the talk really diving into 3 insights from the paper. One that illustrates kind of a big problem that we see. Second, a simple solution that we think anybody can easily implement within their studies. And then third, kind of dig into what makes a really good solution. So some additional kind of details that we think might be useful to guide research design. All right, so when I talk about remotely sensed maps of deforestation, what am I actually referring to? And here, this is kind of a fake version of what the Hansen data might actually look like if you download it. And you get 2 different rasters. One is, and this is a little bit simplified, but you have one raster that's just forested or not forested. It's actually kind of percent forest cover, but you can kind of collapse that into a forested, not forested raster. So every pixel is telling you a binary, is this pixel forested in dark blue and not forested in gray. And then you have a separate raster that's telling you the year of deforestation. So what year was that specific pixel cleared in? And here I just have it kind of ranging from 2000 to 2006. So I can use that data to create my initial kind of forest cover map, but then also to create these rasters that are tracking changes in forest cover through time, right? So those deforestation data tell me the first instance in which a pixel was deforested. It tells me, okay, was this pixel not deforested, which I'm denoting with 0, if it was persistent forest in the year 2005, right? So that started as forest and it continued as forest in 2005. It turns bright pink in 2005 if that pixel was detected as deforestation. But one problem is that those data points, right, after they've been deforested, if you track this kind of pixel that turned pink in 2004, in 2005, I can no longer observe whether it's been deforested again because it's already been cleared in the past. And so typical practice in the econometrics literature has been to just drop that pixel if it's been previously deforested, make it an NA. So we observe deforestation, the expansion of deforestation across this landscape, and the accumulation of deforested pixels through time. A couple data characteristics about this. It's really nice because it's wall-to-wall data at fine spatial scales and over relatively long time series, right? So this is why I can go and study the Amazon soy moratorium that was adopted back in 2006. I can look at the deforestation trends leading up to the adoption and after the adoption for a decade, right? That's really nice data to have access to be able to do these kind of ex post studies of past conservation policies. The fine spatial scale, so in this case, 30-meter resolution, allows me to look right along that Amazon biome boundary and see how deforestation rates differed on either side of that boundary. The wall-to-wall data allows me to go anywhere in the world. I hear about some interesting conservation policy that was adopted, back in 2008. I can go wherever that policy, wherever CI or TNC adopted that policy and actually dig into what the impact of that policy has been. So that's part of the reason why we've seen this rapid expansion of the use of these remotely sensed data products in understanding the impacts of conservation policies. It's just a wealth of information. However, there's two characteristics about this data that I think have been they've received too little attention. One is that we're actually looking at binary deforestation events, and it's largely irreversible in the data structure. So I can't see the regrowth of forest, at least with this data product. But often, like the work that I'm doing in Indonesia, we're often interested in primary forest clearing, which is actually, an irreversible event in human timescales. It is an irreversible process that I'm trying to model. So this binary irreversible characteristic will become really important as I dig into some of the challenges that we found in applying standard econometric methods to this specific data. All right, so when I talk about econometric methods, what exactly am I referring to? So I'm going to be focused on panel methods. So you might have heard of difference in differences, before after control impact, or like two-way fixed effects models. That's kind of the suite of tools that I'll be looking at. We could extend this to a variety of other quasi-experimental methods, but we've kind of gone to the bread and butter of a lot of econometric impact evaluation for this first study to just kind of dig into what are some of the challenges that emerge when we apply those tools to panel data or to panel remotely sensed data. So if we go back to my kind of Amazon soy moratorium motivating example, right, we've calculated this deforestation rate within the Amazon biome. How would we think about creating a counterfactual? Well, maybe I know that, the Amazon biome was kind of unique in that that's where the corporate policies were targeted, but the government actually adopted a whole lot of other policies, right? So this decline in deforestation, you can see predates the ASM. The massive decline in deforestation might give you some, cause for optimism that the soy moratorium was effective, but the fact that it started 5 years before the Amazon soy moratorium was adopted, well, what does that actually tell us, or 3 years before? What does that tell us? Is it actually the result of the soy moratorium? What I need is some counterfactual to understand what would have happened without the soy moratorium. So if I look at the Amazon biome, maybe I could compare it to the legal Amazon, but Cerrado biome, an area that was kind of exposed to a similar set of government policies, but not the same corporate deforestation commitments, and track how that changed before and after the adoption of the policy. And we can see that although in the Amazon biome, deforestation kept declining after 2006, in the Cerrado biome, it kind of leveled off and increased over time. In our actual study, we actually used something called a triple differences method, where we're also comparing soy suitable to non-suitable areas, trying to dig deeper. But the key idea here is that what we want to do is compare these two regions before and after the policy was implemented to try to get some sense of that counterfactual. And the way we do that is we look at that difference before, and we're going to add the difference from before to the actual trend line in the Amazon biome. Before the Amazon biome saw slightly more deforestation. So if we assume that continued out into the future, we can measure the ATT by comparing that counterfactual where we've added the kind of pre-treatment difference to the post-treatment and measure that ATT. So that's kind of largely what we're trying to do when we do a difference in differences. The actual implementation is through a regression. So we're going to run a regression where we've got YIT, our deforestation for a given pixel at time t, is some measure of the kind of whether you're in the Amazon biome, DI, and whether you're in a time period after the adoption of that policy, 2006. And so we include coefficients estimated for both, those dummy variables, but then also their interaction. And the coefficient on the interaction term, beta DID, is really what is our estimate of the ATT. That's what we're trying to get. That will tell us, what was the impact of the Amazon soy moratorium. Another way that this is often implemented is through what's called a two-way fixed effects regression. This is also called a generalized difference in differences. And you can see they're very similar. The only difference is that instead of having a single dummy variable for whether you're inside the Amazon or not, I'm going to have individual level fixed effects, both for the unit of observation and for the time period. And so I've got now, a single fixed effect for every one of the years and for every one of my units of observation. In theory, this should yield a very similar estimate of the ATT across these two models. And the reason I use this kind of soy moratorium example as a motivating case is, when we did this study, we had submitted it, a reviewer came back, I had run a difference in differences regression. The reviewer really wanted me to run this two-way fixed effects regression. Their argument was that these gamma I's might actually be capturing unobservable characteristics of the individual units. So they wanted me to control for those unobservables by including unit level fixed effects. I ran that model. I expected it to, go really smoothly and give me the same answer as my difference in differences model. In reality, I got a wildly different result. The sign had flipped. All of a sudden, my results were crumbling. I was a poor postdoc who was just about to cry because all of my results were falling apart. What do I do? Which of these two models is right? And so that's really the motivation that we dove into trying to tackle in this study. How do we understand which of these two models can give us the right answer? And why do they differ? That really shouldn't be the case. We don't think that that's the case. So we turn to both analytical proofs and Monte Carlo simulations to try and dig into that question. And I'll just kind of dive into the Monte Carlo simulations, not the analytical proofs today, given time. But what we do is we generate a landscape of a bunch of different pixels, and we're going to group them at different scales. So you could do grid cells. Often people run analyses at these kind of aggregated uniform grid cell scales, or at counties, so we can create fake administrative units that span a bunch of pixels, or smaller administrative units, which we call properties. So really small scale kind of control of land and how that might affect deforestation. We observe the landscape across T time periods. So we're going to create those simulations for multiple stacked years, often like 10 years in our simulations, and we're going to impose some policy. So here, imagine this is now in bright blue, a protected area that's been dropped down on this landscape. And we want to figure out what the effect of that protected area was. So, in the initial time period, this pixel was not treated by that protected area. And then in the second time period, it is treated by the protected area. And then we're going to deforest across that landscape. So we're going to have some random process that's simulating binary irreversible deforestation events. So this pixel in the first year was not cleared, but in the second year it was cleared. And the way that we're going to simulate deforestation is a function of a bunch of different parameters. So we have a baseline deforestation rate in the control units, a baseline deforestation rate in the treated area, some trend that's common to both of them. So how is deforestation changing across the landscape through time? And then what is this known ATT? So we're going to kind of force the model to have a known ATT, but we're going to introduce a bunch of random variation, whether at the pixel property, pixel by year level, we're going to have these random disturbances that add noise. And so we can run, 1,000 different iterations of this kind of change in deforestation. And what we're really trying to get at is the difference between these two lines. In the right, the baseline plus trend, and the baseline plus trend plus ATT. just looking at those simulated landscapes, can we figure out what is the ATT? That's the experiment that we're running. How do we evaluate the different models? Well, we know the ATT because we've forced it to have a certain value. We can run some econometric model against it, and it'll give us an estimate of the ATT along with some confidence interval, and we can compare how that estimate lines up with the true known ATT. So in this case, the model looks pretty good. We've got another model that looks pretty awful, right? So this model, maybe this is, the first one is our DID, and the second one now is our two-way fixed effects model. That's kind of concerning. So now we've got another estimate of that same ATT, which is nowhere near the true ATT. We can run that over 1,000 different simulated landscapes to start to get a sense of what is the bias of each of those models. So how far off is the mean value from model 1 to the true ATT? How far off is the mean value of model 2 to the true ATT? Model 2 doesn't look so good. The other thing we can calculate is something called coverage. And so here we're going to look at whether that 95% confidence interval for each of those estimates actually covers the true value. So in that first model result, yes, the confidence interval overlaps the true ATT. Great. Coverage, we find that it's covering that true value 9 out of 10 times. So we would say that has, 90% coverage. If it's a 95% confidence interval, we actually want that coverage to be 95%, right? That's the kind of metric that we're targeting, is that our confidence interval actually is a reliable estimate. Both, the estimate is in the right place and our confidence intervals are giving us a good estimate of the uncertainty of that estimate. So we want 95% coverage. Model 2 has a 10% coverage. That's a pretty unreliable estimate of what the impact of this policy has been. Great. So we've got our kind of diagnostics covered. And now we're going to throw that simulation model at a variety of different model structures. We can change the scale of fixed effects or the unit of observation to be either the pixel, the treatment, so this is a standard difference in differences model, the county, the grid cell, the property, right? Lots of different ways to aggregate the data. We could change the functional form. So often when I'm working in an interdisciplinary group, ecologists are like, well, why aren't you using a probit or a logit or a Cox proportional hazard survival model? We can throw all these different functional forms of the econometric model at the data set and see how that changes the reliability of the estimate. We could change how we calculate deforestation rates. So there's, in the land change literature, a big discussion about how do you actually calculate annual deforestation rates. We can use those different metrics to see how they affect the performance of the econometric model. And when we start to do that, we quickly identify a big problem. So that pixel level two-way fixed effects model that's often used in econometric studies does not actually estimate the ATT. So if we go back to my kind of moment of panic as a postdoc, right, we see that this difference in differences regression is giving us a different estimate. Which model is right? Well, I can plot the bias of these 1,000 simulations from the difference in differences model, see that it's actually kind of centered right around the average treatment effect on the treated. What happens when I do the two-way fixed effect? It's pretty biased, and almost no kind of estimates are lined up right with 0. Even more troubling if I change some of those baseline parameters. So all that I'm going to do is start to change the difference between the treated baseline and the untreated baseline. Pre-treatment kind of differences in deforestation rates across places that were affected by the policy and were not. In this initial one, it was 0.01. I'm going to start to increase that difference, and I can just force that bias to be as large as I want. I could even flip the sign. I could force it to go negative. I can manipulate it however I want by changing the difference in those pre-treated baselines. That's a property that I really wouldn't want in a reliable estimator of conservation policy impact. And in the proofs, we show that this kind of estimate, the beta two-way fixed effects, really is giving us an estimate of the ATT plus whatever that baseline difference in deforestation rate. In effect, the two-way fixed effects model is behaving as if we just dropped all of the pre-treatment data. It's just an after comparison. It doesn't even look at really the before data, even if you're including it in the regression. That is a fundamental problem we think that the community hasn't really been aware of. And so we want to draw attention to that. Fortunately, there's a really simple solution. So aggregation can yield an unbiased estimate of the ATT. We start with this really biased estimate. We already showed that the difference in differences model. So if we just use a fixed effects at the scale of treatment, then we get a reduction in that bias. That's pretty dramatic, but we could also kind of use fixed effects at the county level, at the grid level, or at the property level, which have been done in the literature. I've used those just kind of by accident, right? I not really motivated by this problem. I think there's a lot of people that kind of are choosing these based on what data is available, but we're making the argument that you really don't want to use just individual pixel level fixed effects. We can also vary the scale of the units of observation, so aggregate to a county grid or property level, and those also perform quite well. So all these black dots look like they're performing pretty well, right? So that's good news. But what might we decide between each of these different model structures? Why might we want to do a model at a property unit of analysis over just a standard difference in differences? So the more complete answer is that we actually might want to match the model structure to the scale of real-world decision-making that we believe exists within a landscape. So what I'm going to do in this experiment is show you the effect of property level disturbances. If there are some property owners that are soy farmers that are really actively clearing a frontier, and other property owners that are using non-timber forest products harvested from the forest and not actively deforesting, right, we might think that those individual property owners are a big part of what determines whether a given pixel gets deforested. So we're going to introduce these unobserved kind of sigma p's, and the larger that number gets, the more property level disturbances determine deforestation rates within the kind of pixel nested within that property. So if I increase that sigma p, all of a sudden we see the difference in differences model where we've got these fixed effects at the treatment level start to diverge, get higher bias, the coverage starts to erode, a lot of reasons why this model is starting to perform really poorly. How do we fix that? Well, what we can do is actually structure the model to try to control for those property level fixed effects, to kind of remove those property level unobservables. And so we can match the scale of our model to the property level. It starts to perform way better. Our coverage is back, bias is much lower, right? So by matching that scale of the fixed effects to the scale of decision-making, that's a potential solution. If you don't actually have property boundaries, kind of an intermediate would be to just use a grid that's about the same size as those properties, right? There are ways in which you can use unstructured data to start to correct that problem. But what we find across a variety of different parameterizations of the simulation model is that in general, if you think there are these property level disturbances, a property level model actually does quite well. All right, so just to kind of end, that was getting pretty deep into some of the technical details. For me, I love this community because it really is the confluence of a variety of different practitioner, ecologist, economist communities, political scientists. This is a really rich discussion. What, for me, does this highlight for a field like conservation biology, which is inherently interdisciplinary? I think interdisciplinary collaboration opens the doors to new data and methods. There's been kind of a huge explosion of information about the impacts of conservation policies through this application of econometric methods to remotely sensed data. Causal inference plus remote sensing has yielded critical insights to guide more effective conservation, but it really requires caution. Standard tools from one field may need modification for others. And so in the full paper, I've just given you a bit of a taste of what we're doing, some of the high-level results, but we also dig into selection bias due to attrition, survival model designs. I think this is a really interesting area where people haven't thought about how to modify survival models to work in this kind of difference in differences setting. And so we propose an estimator that gives an unbiased estimate of the impacts of a policy using a Cox proportional hazards model. What is the impact of different measures of deforestation? So how you're calculating deforestation in those aggregated units is important. What about some of the concerns that have been raised in the econometric literature about two-way fixed effects models around staggered adoption or heterogeneous treatment effects? We touch on those as well and show that our kind of proposed solutions are robust to these more complex data settings. But if you kind of look at the paper, this is a QR code that gives you access to the current draft. Feel free to email me or Albert. We'd both love to talk with you. We've been enjoying kind of walking out on this, and we have the whole structure for the simulation model. So if the thing that you're really struggling with in your research setting isn't listed here, maybe it's something that we can tweak our model and really test. For me, this has become just an incredibly useful tool to explore, okay, I've got a new study setting. Which way should I be calculating something? How should I be structuring my model? Can I actually simulate the properties of this setting to know how I should approach my research question? And we're thinking about creating kind of a shiny app to allow people to play with those different parameters and see how different models might perform in their own research setting. So if that sounds exciting, let me know, because then I'll invest a bit more time in trying to get that upline. Great, and thanks so much. I look forward to hearing all of your questions.
Great, thank you, Robert. Really compelling work and important, and thank you for sharing that moment during your postdoc when you saw the signs change and really stuck to your efforts to investigate what was going on and improve these methods. They're really relevant. So I'd like to lead off with a question. As people know, there's a lot of concern in the voluntary carbon market about the quality of carbon offsets and efforts to improve our understanding of how additional they are through applying more advanced methods. How do you recommend that practitioners and researchers alike consider your advances in that context?
Yeah, so I think the key papers that have been getting a lot of attention over the last few weeks and over the last year, Thales Weston, we've had kind of one of these sessions really diving into it. They use a synthetic control approach, which I think is quite rigorous in that setting. And they aggregate in a way that I think addresses a lot of the concerns that we raised. So I don't think the key point that I've made here, where it was really a concern about pixel level fixed effects models, doesn't kind of undermine their conclusions. I think that's great. I think more broadly, there's a really interesting opportunity because we're getting quicker and quicker access to these remotely sensed data products, where we have a set of tools that allow us to kind of infer changes. A lot of the baselines within these offsets programs are designed ex ante. We kind of think of what that baseline might be going forward. And I think there is a lot of opportunity to think about how we might use rapidly emerging remotely sensed data to update our baselines more actively, have some ex post kind of estimation of those baselines, which could improve the rigor of those offsets programs that you're actually responding to on the ground changes in control units, how those are affecting kind of the deforestation rate, or how their deforestation rates are changing, and use that to create more reliable inference around the impacts of offsets. Or you could imagine kind of doing some RCTs and actually trying to adjust the amount of credits being generated based on what we're finding from those RCTs. I think there's a huge opportunity to more carefully integrate impact evaluation into offsets programs to build confidence in those nature-based climate solutions.
Great, thank you for that answer. All right, now I'm going to turn it over to Seb, who will be moderating the Q&A, and I'm glad to see that we have some great questions already coming into the chat. So please go ahead and put your questions into the chat, and Seb will select them for Robert to answer.
Thank you, Sheila, and thank you, Robert, for a wonderful presentation. And there's been a lot of questions, and especially many people making the links between the recent advance in the difference literature in apply econometric literature and trying to find connection with your own contribution to the specificity of deforestation and remote sensing data. So that's very interesting. So we'll get to those but before we start on the very technical one, let's start with general level questions. And someone asked that the understanding of the intuition of your results imply that there is no way, without more information, to sign the bias in the prior studies that I use problematic design. Would you say that correct? Or you have more than an intuition?
No, I think that's right without additional information. But if you went back and you calculated the pre-treatment deforestation rates, which are observable in both the treated and the control units, you could then sign that bias, right? It's really just the bias is equal to that pre-treatment difference in deforestation rates. So I think there is a way to get at it. It gets more complicated because a lot of the studies that do that have, staggered adoption. And so then you're calculating over different time periods, but there's a way to go back and calculate it. We've tried to avoid kind of digging into individual studies and just kind of pointing out a broader general problem. But I think that is an area where we could go back and try and understand whether specific studies we think that bias might be important or not in the interpretation of the results is possible.
Okay. And so as you mentioned, the staggered design, there's exactly a question about how you consider Callaway, Santana, Roth, the staggered design. How do you consider in relation with the issue they raise in relation with the specificity you raised? How do you see the articulation and solution forward?
Absolutely. So as we were kind of initially working on this paper, the kind of econometric community was rocked by a lot of studies that started to highlight that these two-way fixed effects models have other problems that are in addition to what we articulate. And those are even more general that apply to basically any time you're using this kind of two-way fixed effects model in a setting with staggered adoption or heterogeneous treatment effects. Really important contributions there. We have a whole section of the paper where we take Callaway, Santana, Gardner, Sun, we take a bunch of the proposed solutions and we throw them at our simulated data sets. And we show that, even if you're using Callaway, Santana's correction, if you still are using the same data with the remotely sensed kind of challenges of irreversible binary outcomes, you're still going to get wildly biased estimates. But if you kind of correct the data in the way that we do, or you aggregate, you use different scales of fixed effects, then you can remove that bias. And those different corrections like the Callaway Santana give you an unbiased estimate of the treatment effect. So I think, I would direct those people to that's getting more into the weeds of the econometrics, but we definitely think there's a way to address all those concerns. It's a distinct problem, but not an inconsistent problem that we've identified.
Oh, wow. That was a perfectly clear answer, at least from my point of view. Thank you for articulating it so well. Another researcher asked, how does matching on pretreatment outcomes affect the bias you find, specifically on the two-way fixed effect-based estimate? Yeah,
so we don't explicitly incorporate matching in our model, but you'd imagine that if you're matching on unobservables, and you're getting the treatment and control units through that matching to have a more similar pre-treatment deforestation rate, you're reducing the bias. So if you were using a pixel level fixed effects model, but you were matching pixels to each other, the matching would help you reduce the bias that might emerge from that model. So that's great. More broadly, like this paper, I think we would need to have a more complicated data generating process to really articulate the value of pre-matching before the panel model. I generally, Paul has a really great paper where he looks at an RCT and applies, a standard matched model, a standard kind of panel model, and then the kind of combination of those two. And it clearly shows that the combination of pre-matching or pre-weighting your data on observables and then running a panel model after that yields you a much less biased estimate of what you would get with an RCT. So I think that would maybe be the paper I would point you towards for that specific question.
Okay, thank you. So something probably slightly related, someone suggested that they think the treatment bias comes from the fact that treatment is assigned to units that are already deforested at treatment. So first they ask, is that correct? And does the bias in pixel level fixed effect estimations disappear when the sample is restricted to pixels that are still forested at the start of the treatment.
Correct. So I think the problem is if you restricted your sample only to pixels that were not deforested, then you're, again, not capturing the difference in pre-treatment deforestation rates, right? So once you start to aggregate to the grid cell or the county and you're calculating an aggregate deforestation rate for that grouping, then you're able to kind of keep those pixels informing what your pre-treatment difference is to help estimate what the difference in differences is, right? But I think, I think that was a question from Elias. Yes, part of it is that you're dropping or you're ignoring these pixels, but in effect, we're actually dropping those deforested pixels. So I think, we actually have an appendix where we show it's identical to if you dropped all those deforested pixels from ever contributing to the estimator. You get the same estimate of the treatment effect. And both of those are somewhat problematic because they're ignoring pre-treatment deforestation rates. And maybe I'll just say one other thing, like the reason we think this is super important in the conservation setting is because part of the selection bias that we worry about in conservation settings is explicitly because there's a huge difference in pre-treatment outcomes in treated and control units. That whether you're thinking about protected areas that are maybe on rock and ice, they have really low relative deforestation rates, or you're thinking about the kind of commodity supply chain interventions that I study where they're going into like active agricultural frontiers. And so you're adopting a policy specifically because that area has really high deforestation rates. Both of those would give you a prior that there's a dramatic difference in deforestation rates prior to the intervention. So we want to be able to adjust for those pre-treatment differences as we estimate the impact of a policy.
Thank you, Robert. So we are slightly moving to a different part of the question, moving from pre-treatment differences to more. People are intrigued by your simulation and your recommendation regarding the level of the unit of analysis, and they specifically ask with real-world data, you won't necessarily know the level at which those key decisions will be made. Is there a way of understanding what level of aggregation will be best? So switching from simulation to actually empirical challenges.
Yeah, it's a super interesting question. I mean, in my mind, often what we want to do coming into one of these exercises is to have a deep understanding of the local context. And so you should ideally have a prior over what kind of decision making is influencing the decision to deforest. Whether you're in a landscape where private property owners exert a lot of control over their land and determine those outcomes, or whether it's state level or county level regulators that are really influencing those decisions, that can help you kind of think through the design of your model. I haven't really thought about the idea that, is there a way to look at correlations? And I'm guessing you could do some kind of exercise with a semi-variogram, and you're looking at the scale of variation, spatial autocorrelation in decisions at different scales and trying to actually parse that out empirically, but not something that I've done. Super interesting, and would love to dig into that a bit more.
And have you, or do you plan to reanalyze some past papers more thoroughly?
I have decided not to do that so far. I mean, if there is a paper that somebody, especially if somebody is like a co-author in a paper and they want to dig back into it, like I would be eager to collaborate and look into that. For me, I've felt providing constructive paths forward has been the best use of this research. And so really focused on just articulating what the fundamental problem is, how that might lead to changes in our interpretation of certain results, but not getting into the specifics of individual studies so far.
Great. So we have a lot of questions, probably that more specifically to your case studies in Amazonia, and people are particularly curious, how do you control for potential spillover affecting your control region? So on top of all the problems you mentioned, you also have on top of that spatial spillovers.
Absolutely. And so this is kind of a fundamental challenge for the non-econometricians. It's so we call like a SUTVA violation, where you've got some way in which the reduction in so in the Amazon, the example is a lot of people are worried that the Amazon soy moratorium might have pushed deforestation into the Cerrado, right? And so you actually have the policy itself is affecting both the treated units and the control. And if the control is increasing in deforestation as a result of the policy, we would be overestimating the impact of the policy, right? That's a fundamental concern when we're trying to estimate a causal effect. It's one of the core assumptions that we make when we're designing these models, that there is no spillover. So I can't remember whether it's in the appendix or like towards I think we actually ended up including it in the main part of the paper, because reviewers, this was their kind of thing that they kept going back on this paper, was what are the spillovers? And you can imagine a wide variety of spillovers in this context. Maybe farmers are shifting deforestation to livestock production, or like within their properties, there are spillovers, or maybe it's over to the Cerrado, or a variety of different ways in which we might imagine spillovers that could cause problems for our analysis. And so we run a bunch of different tests where we're actually comparing like deforestation patterns in the near Cerrado to the further away Cerrado, or deforestation patterns, in monitored properties to unmonitored properties. And so we have a bunch of different ways in which we try to dig into those spillovers. We don't find a huge amount of evidence to show that there's a ton of spillovers. That's somewhat consistent with some recent work by Nelson Deloria and co-authors looking at kind of broader spillovers from the Amazon soy moratorium. But yeah, we try and address that, and we try and structure our models so that we're less exposed to those types of SUTVA violations. And so I just refer to that part of the paper. There's also, I'll maybe point to another paper that I really like that we published in ERL a few years ago. This is kind of jumping to Indonesia. We were looking at spillovers from RSPO certification. And there, I think it's a bigger challenge with some of these commodity interventions where we actually don't think spillovers. Often we model spillovers as these very proximate spatial processes. But if you're thinking about a big commodity production process, right, a spillover might be from one Wilmar controlled concession to another Wilmar controlled concession. They might be reallocating resources from their certified concessions to their non-certified concessions. And so in that paper, we kind of provide an interesting way to think about spillovers as geographic space and more economic space, and how you might try and detect spillovers in those contexts.
That's great, thank you. So there's still a lot of questions, so I will send you the question by text after, and people asking question, not answer, feel free to reach directly to Robert. I'm sure he will find time to discuss that with you. But probably very, very shortly, in 1 minute, what will be your recommendation to, let's say, junior people who do not are as great an econometrician as you are? What will be the key takeaway for junior people wanting to apply some of your findings, or at least reduce the bias as a designer studies, in a few words? If you can.
I mean, literally, if you have a study that you're working on, and I've worked with some of our PhD students here at UCSB, like you can aggregate your unit of observation even to like a relatively small grid cell, and that's going to solve like the really top line problems that we identify. If you want to dig into the weeds of the paper, there's a bunch of other kind of secondary guidance that we provide. But I think more broadly, like maybe go make some friends in the econ department, chat with some of their PhD students. I think one of the exciting things about being a PhD student, being on an active research campus, is you really can find people that are grappling with your problem, but in a very different context, that have a different set of skills and knowledge. And so I think that's a really good opportunity that you have while a PhD student.
Thanks, Robert. Sheila?
Yeah, thank you for summing that up and encouraging collaboration as well. Well, thank you, everyone. It's great to be back with the seminar series up and running. We will have a presentation by Michael Masha in October, again, the first Tuesday of every month. So you will see a reminder coming from Rachel, and we are just so pleased to see how large this group has grown to and continues to create space for important conversations. So in our final minutes, I do want to turn it over to Seb, who is going to talk about the Society for Conservation Biology Impact Evaluation Mentoring Program.
Hi again, it's me. While we still have people, I just want to tell you that we are launching again our mentoring program. So the idea is to connect any learning mentees who feel not yet confident as they design the impact evaluation, or if you are a practitioner not slowly, but just starting learning this type of approaches. So we are creating this mentoring program to help you match with someone who is more confident and has more experience learning that, so that the pair can discuss together many different aspects. It can be only on methodologically guidance or help in the design or feedback, but it can be more generally, what does it mean to be an impact evaluator in the conservation context, or working in non-profit sector, in other organization, in academia. So that's a great opportunity to connect, learn the things, and for mentors, that's a good opportunity to actually teach all the skills you have accumulated while you learn about impact evaluation, and try to help someone who is just starting to start. So I encourage everybody to apply, whether you want to learn or if you already have the confidence that you can teach, and you don't need to be a stellar econometrician with 10 papers or more. I mean, as long as you have completed one impact evaluation, you probably know much more than many people who can benefit from you, and that's a good preparation if you want to follow your career in academia, or even if you want to get more exposed to challenges faced by junior researcher, and especially in applied context. So I will send all the information. From now, I will just copy the link to the text in the page, but we will send an email today for helping everybody, and we will disseminate mostly on Twitter and through our newsletter. So feel free to apply, and we are especially looking for mentors, whether you are a grad student, PhD, postdoc, researcher, even if you work on an NGO, there's a lot of demand. There's a lot of mentees interesting, so we are really looking for a lot of mentors to help them. So feel free to reach out to me if it's unclear, but we will send the emails today. Thank you.
Thank you, everyone, and see you next month.